everybody. Today we're going to continue on with hypothesis testing. This time we'll be looking at hypothesis tests for a population mean. Now all the ideas and vocabulary and procedures that we had before are still going to work for the population mean. However, we need to use a different type of table because we can no longer use the standard normal or Z distribution. We have to use something called the student's t-distribution. So that's where we'll start. The student's t-distribution is very similar to the normal distribution. It's centered at 0, it's symmetric about the mean of 0, and it's a bell-shaped curve. What do you think the total area under the curve is? I'll give you a hint. It has nothing to do with the type of distribution. The total area under any probability distribution curve is always 1, because total probabilities of all possible scenarios always adds up to 100%. But the t-distribution differs from the normal distribution in that area in the tails is greater than for the normal distribution. So let's compare the two curves. On the left here we have two bell-shaped curves. They both happen to be centered about their mean, which is 0 in both cases. Now the one on the top is the standard normal, or Z curve. The one that doesn't go up as high, that is the T curve. And notice if you look out at the ends, out where the tails are, there's more area under the T curve than there is under the Z curve. So the Z curve has more of its area, more of its stuff concentrated in the center, and the T curve has more of its stuff, more of its area out at the ends. We'll come back to this other diagram in a little bit. Now there's something called degrees of freedom that we did not have to deal with in terms of the standard normal curve. Degrees of freedom is a characteristic of the t-curve, and it affects the shape of a t-curve. The way this is going to get into action for us is for a sample size n, the t-distribution will have n-1 degrees of freedom. And I'm not going to get into that, why that is, or even exactly what degrees of freedom are. For us, it's enough to know that each t-curve has a certain number of degrees of freedom, and if you change that, so in other words, if you change the sample size of the sample you're working with, that means you have to use a different t-curve. And we'll see that as we go on. So the t-distribution is different for different degrees of freedom. That's what I just said. The number of degrees of freedom affects the shape of the t-curve. And what that means is that unfortunately there's no one standard t-distribution. With the normal curves, there's one standard one that we call Z, but that's not the case with the t-distributions. Now, as the number of degrees of freedom increases, in other words, as we use larger and larger sample size n, the t-distribution actually becomes closer and closer to the standard normal Z distribution. So let's go back up to that picture that I skipped over a little bit ago. The lowest curve on here is a t-distribution with 1 degree of freedom. The next one up is a t-distribution with 3 degrees of freedom. The next one up from there, and now they're getting so close together, it's kind of hard to distinguish them, The next one up from there is a T with 10 degrees of freedom, and the one on the very top is our Z, or standard normal. So you can see that the degrees of freedom affects the shape, and as the number of degrees of freedom goes up, the graph gets taller and closer to the standard normal Z graph. Again, these are all centered at 0. They all have mean 0. By the way, some notation that we will find helpful is if you see T sub alpha, so I put a little subscript alpha on my T there, that means the T value with area alpha to the right of the T value. So, in other words, if you've got this T distribution curve and you pick some T value where the area to the right is alpha. Alpha is just the Greek letter A, so A for area. We call that T value T sub alpha. That's probably a good stopping point. So we'll come back in the next video and talk about using T tables. See you then.